When you think about the great astronomers and physicists of history, which names come to mind? Galileo? Newton? Einstein?
Well, it turns out that many women have made vitally important contributions to our understanding of the cosmos, even if many of them haven't received the recognition they deserve. In this episode, we look at two books that try to rectify those omissions.
This is BookLab. Welcome to episode 36 of BookLab, the podcast where we check out what's new in the world of popular science books. I'm your host, Dan Falk.
And I'm your other host, Amanda Gefter.
In Her Space, Her Time, Shohini Ghose looks at dozens of trailblazing women scientists who helped to figure out the nature of everything from atoms to stars, and even how the universe got started.
And in The Enlightenment's Most Dangerous Woman, Andrew Janiak looks at the life and ideas of Émilie du Châtelet, the 18th century philosopher who absorbed all the big ideas of the age, but still remained fiercely independent in her thinking.
But first, Her Space, Her Time. Our first book is Her Space, Her Time: How Trailblazing Women Scientists Decoded the Hidden Universe. The author is Shohini Ghose. Ghose is a physicist at Wilfrid Laurier University in Ontario, Canada. The book is divided up into chapters, each of which covers a specific subject, so some particular aspect of physics or astronomy or cosmology. And then within each chapter, she talks about a number of specific women. The first chapter I actually found quite interesting. It's about astronomy, which is a subject very close to my heart. And she talks about the group of women known as the Harvard computers. Now, of course, the word computer has evolved. So today we think of machines such as the laptop that's in front of me. But here we're talking about the early years of the 20th century. And at that time, computers were people who did computing, and more specifically, people that you didn't have to pay very much, which means women, which is very unfortunate. So this is the universe, so to speak, that these women were living in. And some of them, some names like Annie Jump Cannon, Henrietta Leavitt, these may be names that listeners will know. Certainly if they've read a little bit about the history of astronomy, they'll know those names. Some of the other women, I suspect readers will not be so familiar with. And just to set the stage a little bit, so what was going on in astronomy? So, of course, the telescope had been around for a couple of centuries already, but by now telescopes were very good. They were much bigger than they had ever been before. And photography had come along. So this was a huge breakthrough. So instead of just like sort of sketching or describing what you saw through the telescope, you had a, so to speak, objective record of it. So you attach a big bulky camera to the back end of the telescope. There's a photographic plate in there. You expose it for some time, and then you have these. So everything's reversed. You get black dots where the bright points of light are. Anyway, so you get these photographic plates, and then they have to be studied, and the specific stars have to be categorized, and the intensity of light has to be measured. Or if you're using a spectroscope, then you try to get the spectrum of these individual stars. So in other words, there's lots and lots of data that's got to be crunched and mined looking for interesting facts. So this is kind of the scene where these a dozen or so women come into the picture at the Harvard College Observatory. So that's, of course, in Cambridge, Massachusetts.
Yeah, I thought it was amazing. I knew some of this sort of vaguely, but I thought that Ghosh did such an amazing job of sort of like bringing it all to life. Like you sort of felt like you were in the room with them. And yeah, she's talking about in the beginning these women who are doing spectroscopy, as you mentioned, where they're having to analyze on the glass plate images of the stars that we're taking from the telescope. They have to analyze like the chemical compositions of the stars. And I'll just read a quick paragraph here just so you get the sense of the writing, which I just love. She says, They worked together in a large, well-lit computing room at the observatory. The dozen or so women often paired up like binary stars, the one scrutinizing the plate with a magnifying glass or microscope, calling out observations, while the other orbited close by, noting down her calls. Imagining a room in a scientific institution echoing with women's voices fills me with joy. It's still not a common occurrence today. And it goes on like that, but it just she really does sort of bring it to life in a lovely way. And she also does this great job of calling out just how ridiculous it was that this kind of work was referred to by the Harvard administrators as secretarial work,
Yeah.
right? While so they were the computers doing the secretarial work, while the men that were operating the telescopes were the astronomers, right? And the claim at the time was that, well, this job requires patience and organization, and that's, particularly suited to women. And Ghosh writes, who knew that astronomical spectroscopy was a skill akin to arranging the kitchen cupboard?
Yeah.
Because if you think about like they're analyzing these images, they're extracting data. Like they're not just,
Yeah, they're
noting down things people are saying.
no,
Like they're
they're absolutely
actually
totally being
they're
scientists.
being scientists, and like so much of today what anyone would call science like fits within
Yeah.
that description. It's not secretarial work, and you can so easily imagine like if it happened to be reversed where like the women were operating the telescopes and the men were doing the analysis, like they would just have a different description. They'd be like, well, the analysis takes like reason and brain power,
Oh,
and
100%. It's
the
just so
telescope, you're just taking a
transparent. Yeah.
picture.
Absolutely.
So, I mean, it just like it really comes across like just how outrageous it was. And, some of these women didn't have degrees because it was very hard for women to get degrees at the time, but some of them did. I mean, some of them really had like advanced degrees in physics and mathematics, and, they're being considered like secretary. It's just, yeah, you really get a sense of kind of how unjust it all was. And, so they were paid minimally. They weren't called scientists. And then we look back in history and say, oh, look, there weren't very many women scientists. And so you just sort of see how that story gets constructed. But anyway, these women, they built up this catalog of the spectra of some 10,000 stars at first. And this was published in 1890. And of course, it was published under a single author's name, and that name was Edward Pickering.
Yeah.
So this was the director, who of course was a man,
Yeah.
and he got all the credit for all of their work. And she also tells the story of Pickering hiring this woman named Mina Fleming, who was a single mother who had worked as a maid and came into the lab where she developed this classification system for the stars based on like the relative strengths of the hydrogen absorption lines in the spectra. And this was used to classify like 300,000 stars. And then we get different women involved. Antonia Mori, who did have honors degrees in physics, astronomy, and philosophy. She sort of used this system, but she also, with Pickering, discovered the first what they call spectroscopic binaries. So this is like a pair of stars that orbit one another, but these binaries can't be picked out using just visible light, so you can't just see them with the telescope. But when you look at the spectroscopy, when you look at the lines, you can figure out that there's a binary system there. So she helped pioneer this whole method of discovering binary stars. She was the one that on her own, calculated the period, the orbital period and the speed. She discovered a second one that was entirely doing this on her own. But again, Pickering gets, all the credit in the publication. Anyway, this story keeps going, and they different women sort of rejig this classification system that Mina Fleming had come up with. And in the end, they have this classification system that all these women have created that everyone uses even today. And the kicker of this that Ghosh tells
Yeah.
us is there's this mnemonic that they came up with for all the textbooks to, for students to remember the order of the letters, the category, the letters that categorize these stars. And the mnemonic is, "Oh, be a fine girl, kiss me." And apparently this is still in astronomy textbooks today, in the same textbooks that never mention any of these women that did any of this work. And Ghosh gave her she tells this little anecdote of like she gave her physics students the task of coming up with a new mnemonic. And the one that she loved is occasionally broken asteroids fall, giving kids meteorites, which I thought
Oh,
was so much better.
it is better.
And
Yeah, yeah,
I mean, it's
much
just
better.
better in general and also not offensive. And that should just be the new one.
Yeah, it's much better. Yeah, so for people listening at home, the mnemonic is to help people remember OBFGKM, which is difficult to remember. So when I learned it, because I took an introductory astronomy course about 30 years ago, give or take, and of course the textbook had "Oh, be a fine girl, kiss me." Now, at that point, there was just like I would say the glimmerings of an awareness that it was sexist.
Right.
um, but I guess what I'm wondering is how backwards, I mean, at that time, at the start of the 20th century, was it just, I don't know, I'm just sort of curious. Like, did anyone put their hand up, or well, was anyone in the position to put up their hand and say, maybe we should think of it anyway? So, but it,
Yeah, I mean, I'm sure if there were any women sitting in the room, I'm sure they were uncomfortable and whether they were able to say something, probably not. I mean,
yeah,
um, there was one anecdote, where there was, just one woman in a class full of men, and the professor would come in every morning and just automatically say, "Good morning, gentlemen." So you can just imagine these scenarios where it's like there's one woman in the class and
yeah.
she's surely picking up on all of these
Yeah.
things, but whether, any of the men are.
Or potentially even worse. I don't think this is in Ghosh's book, but you hear stories like, where there is one woman in a class, so it'll be good morning, gentlemen, and then, singling out the woman,
Right.
but which is, oh my, it makes me shudder
Yeah.
thinking about it.
Yeah. The story, I mean, even in this chapter alone, like the story has so many twists and turns and outrages. But I'll leave those for listeners to read for themselves. But um it's just amazing, like the amount of work that they did, the amount of credit they didn't receive, but also the ways in which their stories intertwined. Like some of them would,
Mm.
live together, and so they all sort of really supported each other, and their scientific ideas intertwine, and she just does a great job of kind of bringing that all to life.
So that chapter is fascinating. I will just mention, so this, the story of the so-called Harvard computers has been written about previously. And for people who want to dive in even further, there is a big, thick book by Davis Sobel. Now, people will remember Davis Sobel as the author of Longitude and Galileo's Daughter and a number of other books. In 2016, she wrote a book called The Glass Universe: How the Ladies of the Harvard Observatory Took the Measure of the Stars. I'm very embarrassed to say that although it's on my shelf, I haven't actually read it, but Sobel is usually pretty good. So there's a place people can turn if they want to dip into that period of 20th century astronomy even further. So each chapter is distinct but quite interesting. So elsewhere we hear about Mary Golda Ross. Now I was not familiar with this woman. She was born in 1908 in Oklahoma. She actually had a nice long life, living until 2008, so 100 years, not bad. She's from the Cherokee Nation in Oklahoma. She worked as an aerospace engineer at the Lockheed Corporation. And amongst other things, she was one of the key people behind the P-38 Lightning fighter plane, which saw action in the Second World War, especially in the Southeast Asia theater. So I just had no idea. And, if there had been a quiz, I mean, if you had asked me, so who is designing these advanced piston engines and the P-38, it's actually a twin engine system. It's a very distinctive airplane. If people have ever maybe seen old photographs of it, there's a single sort of cockpit in the middle, but then there's actually two fuselages on either side. And obviously they're sort of connected and the wing runs through and then there's a twin tail at the back. But at any rate, a very sophisticated airplane. And if you were quizzing me like who designed it, I'd say, oh, well, probably some guy, right? Well, no, in this case, it was this Mary Golda Ross. I found this just to be really interesting.
It was fascinating. She had a line in the book where she says, describing Mary Golda Ross, she says, a woman holding an advanced mathematics degree in the 1930s was rare, and an indigenous American woman unheard of. So, I mean, that was just a remarkable story. I mean, there was another story about indigenous women that I had never heard either, which was about the Fairchild Corporation. This was the first company to make integrated circuits. This was the company started by Robert Noyce, who was had won the Nobel Prize for co-inventing the first computer chip, silicon chip. And apparently, this company was looking for this cheap way to manufacture chips and went to New Mexico, a place called Shiprock, New Mexico, and hired indigenous women from the Navajo Nation because you could basically get away with paying them nothing. There wasn't even minimum wage on these reservations, and
Yeah,
so, no labor unions or anything, and so you could get away with paying them incredibly low wages, and you would get tax credits for using indigenous people. And
yeah,
it's just this awful story, but basically, Ghosh describes like this was hardly unskilled labor. These were people like placing electronics on silicon wafers, like, through looking at it through a microscope. It was like really, really skilled work, and they were doing it for NASA. This was like these were the chips that got the space program off the ground. So they had to be like incredibly, reliable and accurate. And it was basically indigenous women that made these chips, and we don't even know their names. So, I mean, that was just an incredible story.
yeah. And this listeners may be detecting a certain theme here, finding people that you could pay less because you're a huge cheapskate and
Yeah.
and don't want to pay people what they deserve to be paid. So it is just on the one hand heartbreaking, on the other hand kudos to Ghosh for bringing some of these less talked about women to light. A chapter that I liked was a discussion of Harriet Brooks. Now maybe I had heard of Harriet Brooks, or maybe I'd heard of her a while ago and then forgotten, but Harriet Brooks, this was about 100 years ago, give or take. She was at McGill University in Montreal. She was the first woman nuclear physicist in Canada. Interesting distinction. So she worked alongside Ernest Rutherford. Rutherford, of course, was well known for sort of discovering the structure of the atom. And Brooks was amongst the first people to sort of figure out that radioactivity might be a thing, finding the first hints that possibly the atom contained within it sort of hidden energy, like secret energy that's locked inside it, if only you could figure out how to get it out. Now, of course, she did not invent the nuclear bomb. That came decades later, but these ideas are first starting to circulate. And unlike some of the authors who got, like Pickering at Harvard College Observatory, who published everything under his name, doing a huge disservice to those women, Harriet Brooks did get a paper published in Nature with her as the sole author. So that's kind of huge. That's kind of a
It's
big,
huge.
yeah, it's
Yeah.
kind of a big achievement. Today, getting something published in Nature is a big deal for an
For
early
anyone.
career
Yeah.
scientist. Yeah, yeah. But just in case people are thinking, oh, great, some justice, woohoo! But it was the another guy another guy who sort of recreated those experiments a few years later, Otto Hahn, who, well, it's complicated. Like he sort of gave her some credit, but sort of not really. And so a lot of people sort of don't realize that Brooks did a lot of this work initially because it came to be associated with Hahn, and Hahn went on to win the Nobel Prize. So here you go, yet another, how shall we say, misdirected Nobel Prize or
Yeah.
whatever. Maybe it could have been, divided up between them or something. But at any rate, so there you go, a Canadian woman who, even here in Canada, I think people don't know as much as they should about this woman.
Yeah, I mean, another Nobel story that I thought was amazing. I'm gonna butcher the pronunciation of this name, so I apologize in advance. But there was a researcher, a woman named Wu Qian-sheng, who all the way back well, she did a number of actually an incredible number of incredible things. In 1950, she found the first good experimental evidence for quantum entanglement, which nobody references.
Yeah.
She then came up with the experiment that confirmed Fermi's theory of beta decay. And then to top that off, she did an experiment that showed parity violation. So this is a huge deal in fundamental physics, like this idea that there was always a thought that the laws of physics would be like what you could think of as like mirror invariant, that if you
Mm.
sort of like reflected in a mirror some physical interaction, that shouldn't change the physics, like if you swap left and right. And And it turns out that's not true. That parity is violated. The nature is not mirror invariant, as they say. And so she did this key experiment that showed parity violation, and two other researchers, Yang and Lee, who are very famous now, got the Nobel Prize for that discovery. So, I mean, she had a little bit of, what's the word? Retribution. She
Revenge.
got a little bit of recognition later where she won the first Wolf Prize, and the Wolf
Uh,
Prize is sort of now known for like either being like a precursor to the Nobel or like giving prizes to the people that should have won Nobels, and so
mhm.
it's apt that she was the first one to get the Wolf Prize. But I mean the fact that this is a much more modern story, and here we are, and it's the same thing again.
I'm detecting a second theme. So the first theme is people not getting paid what they really ought to have been paid, and the second theme is people not getting the Nobel that they deserve because they gave it to some guy.
Exactly,
Yeah,
exactly. And and the themes are really important because it's like the way they were able to get away with not paying these people what they deserved is by not calling them scientists, right? Like
yeah,
that's how you get to not
yeah,
pay them well.
yeah,
And then that writes history in a very particular way where people get to look back and say, well, but there weren't that many female scientists. Actually, there were tons and they just didn't,
yeah.
have the name. And the same thing with all the recognition. It's like women got recognition that was kind of like a pat on the head, whereas men got recognition that was like a Nobel Prize. So
Yeah.
yeah, you really see in the book like the kind of institutional ways in which this happened.
Yeah, the prejudices are just baked in, and
Hmm.
yeah, and even today we still kind of struggle with them. Um, a chapter that I found really entertaining. Now, I did know who Lise Meitner is, but her story is just riveting, kind of from the beginning to the end. She was a German physicist. We now remember her for doing groundbreaking work in nuclear physics and sort of paving the way for study of the nuclear fission reaction. And her work in, I guess this would be the 1930s. So Germany was on the verge of admitting women to university positions. Never too late, I guess, but it had not quite yet happened when she was working. And so she had, basically all these sort of tricks had to be done to get her into the university. And then when she's there, they forced her to work in a basement, like it was basically a carpenter's shop that had been abandoned. So you can just imagine this poor woman like relegated to this dimly lit, probably damp basement, and probably a lot of people, might have even forgotten that she was there. I mean, the whole idea was to prevent too many people from knowing that she was there, because I guess sort of technically she wasn't supposed to be there. Oh, and as Ghosh points out, and as I'm sure our listeners can imagine, there was no washroom. So she had to go down like several blocks down to a restaurant to use the washroom. And also at the beginning, she wasn't getting paid. So again, these themes that we've mentioned keep coming up. So the story gets more riveting because the Nazis come to power. Meitner is Jewish. And well, at a certain point, so there's a period of think, well, maybe she can stay on if blah blah blah. But of course, the people, other people in the university, well, some of them might be Nazi sympathizers, some of them just want to be left alone, but they feel that the presence of a Jewish person amongst their faculty in their department could bring undue attention to the whole department. Like so it's this really awkward situation. At a certain point, she realizes she's got to get out of there. Like by whatever method, she has to leave Germany, and also like kind of on a deadline because there are rumors circulating that the Nazis are just going to close the border at a certain point, and then that's it. Nobody's going to be going anywhere. So a Dutch scientist, I forget his name, but a Dutch physicist visits Germany and then escorts her by train back to the Dutch border. Of course, the guards are looking for physicists trying to leave, but of course she's a woman. They don't think they don't think she's a physicist. They recognize, or they look at the Dutch guy's papers, but he's Dutch. He has a passport, and however they do it, they've got her some papers or something to visit the Netherlands or whatever. So they cross that border. Eventually, she heads over to Sweden and takes up a position in Sweden. But it's first of all, it's just so dramatic that I don't know why there hasn't already been
Yeah,
a
a
Netflix
movie.
biopic, because I
Yeah.
would absolutely watch it. And also just the irony that basically we've been talking about situations where time after time after time these women were probably thinking, if only people knew, like why don't people, if only I could tell people that or about this important work that I'm doing. And
Right.
here's the one situation where she was probably delighted to be mistaken for somebody's daughter or somebody's maid or something like that.
And on
And
top of it, the physics she's doing is like the physics that's going to lead to the bomb that's going to like end the war and
yeah,
like it's
yeah,
really
yeah,
consequential to the whole political situation. Yeah.
yeah, yeah. And on a loosely related note, for people who are interested in, sort of the development of the atomic bomb and this period, and sort of, Nazis and scientists and all this, Michael Frayn's play from a little while back, Copenhagen, really good play. There is a movie version. The movie version is, whatever, not too bad, not too great. But if people do have a chance to see that performed at their local playhouse, definitely worth checking out.
Yeah, that play is amazing. We could go on and on with all these stories that are in the book, but we'll let listeners read them for themselves. I'll just say, I guess, that Ghosh did an incredible amount of research. I was very impressed by just the amount of work that must have gone into putting this together. And I have to say, I like this book so much more than I sort of thought I would when I first picked it up. I just had this feeling, like based on the cover and what it was, like I was like, oh, it's going to be, like a couple of little biographies of a few women that did some science, and that's not at all what it is. Like the way she organized the book, where it's not like each chapter covers a particular person, but instead it's a topic, and the topics are sort of arranged chronologically. What you end up getting, first of all, is there's so many women. Like it's not about five women, it's
Yeah,
about, I
totally.
don't even know, like hundreds, thousands. And that's the point, is to make you realize like, oh my God, there were so many women that were involved
Yeah,
in
it's
all of
it's
this.
not just Marie Curie, or
Right.
it's not just Marie Curie and two others that,
Right.
it's
That you've like half heard of.
yeah,
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 exactly. And it's so effective because what you really end up getting is sort of a whole history of physics, astronomy, cosmology, but it's like this parallel history that you didn't know. That was sort of running alongside the one that the history books usually tell us about. And I just found that very, very effective. And I also really loved, the writing is great, and Ghosh sort of puts herself into the story a few times in sort of small ways where she reflects a bit on her own experiences being she's a quantum physicist and was often the only woman in the room and struggled, for example, like her partner who she married like was also a physicist, and at some point they had to make this hard decision about like how do they have a family and pursue their careers and whatever. And basically he stepped aside and had her pursue her career, which
yeah,
was a really nice story to hear. And so you get these little bits of kind of personal, intimate details and moments from her life, but they're very sparse. I mean, she doesn't. It's not at all competing with the stories of these women that she wants to like give the spotlight they finally deserve. And it just kind of works to tie the whole thing together. So I really like the way that she managed to pull that off.
yeah. And I was just gonna say, I like her style. Like, there's a little bit of humor, there's a little bit of sarcasm. And by the way, I think in a book like this, a little bit of sarcasm is fine. Like,
Yes.
there are places where it's
Yes.
kind of called for. So yeah, I like that.
Absolutely, absolutely. And yeah, the title grew on me the more and more I read. It's like, okay, yes, we finally have to make, space for these women, and it's, their time has come. And I also thought the book has a fabulous last line, which I will not spoil for anyone.
Yeah, that's we'll leave that one for the reader. Again, the book is called Her Space, Her Time, and the author is Shohini Ghosh. Our second book is The Enlightenment's Most Dangerous Woman, Émilie du Châtelet and the Making of Modern Philosophy. It's by Andrew Janiak. He's a philosopher at Duke. So let me start by saying a few words about who du Châtelet was. She lived in the 18th century. So she was born in 1706 in France. So 1706, so Isaac Newton is still alive for another couple of decades. She was born at around the same time as Benjamin Franklin or the philosopher David Hume, to within a few years, if that helps people sort of place her in their chronology. She did not have a super long life. She died in childbirth. She had previously had several children, and then she died giving birth to a child in 1749. So not a super long life. Today we remember her as a philosopher and I guess we would say physicist, but really more like a natural philosopher, just because it's so long ago that physics as a distinct discipline didn't really exist. And indeed, science, the way we think of the term today, had not yet disentangled itself from philosophy. So if we would call Isaac Newton a natural philosopher, that's probably the best term to describe du Châtelet. Her parents were from the, I guess you would say, lesser nobility, but then she married this guy, the Marquis, who was from an even wealthier family. And so from her marriage onwards, she was quite young. I think she was 18 or so when she got married. The Marquis was substantially older. At any rate, at this point, she had no money problems whatsoever. And also the Marquis, I mean, they were married, but he was always off doing stuff. And as far as we can tell, especially as Janiak explains it in the book, her husband just was sort of content to leave Emilie de Châtelet to do as she pleased. And what she pleased was, well, a bunch of things. She appears to have had an affair with Voltaire, which we can talk more about. But at the very least, she had a lifelong relationship with him, but also seems to have been his mistress. And her studies, well, her studies began before her marriage and very much continued. And she learned all about astronomy and the structure of the world. Um, Astronomy, interestingly enough, she appears to have been tutored by Fontenelle, and I'll just remind listeners who that is. So Bernard Le Bovier de Fontenelle, actually, I think he has more names than that, but that's how he's summarized on the cover of the book that I've got here. He's known particularly for writing conversations on the plurality of worlds. So basically talking about whether Jupiter and Saturn have little green men, so to speak, on them, and whether we live in a multiverse or, whatever the 18th century equivalent of that conversation would have been. It's a very interesting book. And fascinatingly, Fontenelle's book, Conversations on the Plurality of Worlds, is structured as a dialogue between the learned astronomer, who's a dude, and an educated woman anxious to learn. And whether this educated woman is actually based on du Châtelet, I don't know. And unfortunately, I mean, I did some Googling and I just don't know the answer to that. And I don't think Janiak spells that out either, but it's very cool. I mean, just the idea that Fontenelle's book actually might be inspired by du Châtelet is kind of cool. Now, I was rattling off people that she knew. It's a long list. So Voltaire, Fontenelle, La Mettrie. La Mettrie is known for something like a what would you call it? Trying to come up with physical explanations for reality, including the mind. So trying to frame everything in sort of a mechanistic way. And he was also something of an atheist before it was cool. People can email and say he wasn't really an atheist. Well, whatever. He was something like an atheist for his time. Buffon, again, Buffon had like 12 Christian names or something, and then Count of Buffon or whatever. He did important work on trying to figure out the age of the Earth, geology, that sort of thing. Immanuel Kant, I think people are comfortable with that name. Bernoulli, the mathematician. D'Alembert, I hope I'm pronouncing it right, the D apostrophe Alembert. D'Alembert was one of the people who started the first encyclopedia, to which du Châtelet was a contributor, and Maupertuis, the philosopher. So it's just a long list. It's like the who's who of important thinkers back then.
Yeah, there was like Euler, I think that's how you say it, or Euler,
Yeah,
Euler,
Euler, the mathematician. Yeah.
the mathematician, and Diderot, and yeah, I mean, it was just an unbelievable people she surrounded herself with, which they seem to have considered her their equal in at least in intellectual ability, if not in sort of like social position.
Yeah, and actually, let me just say, and this is a little bit embarrassing for me to admit, but when I think of these women who are from the early part of the Enlightenment, the first name I think of is Princess Elizabeth of Bohemia. So
Yeah.
when this book came along, I had this insane thought in my head, like, well, wait a minute, is this the same person? Like, I mean, they're obviously not. Like, there's no way that
Right.
that Emily could be Elizabeth. That doesn't make any sense. But anyway, so I hope people will forgive my ignorance on that subject. Princess Elizabeth of Bohemia lived about 75 years ish earlier. So she's a 17th century figure as opposed to this 18th century figure. Princess Elizabeth had a correspondence with Descartes, and that's what she's particularly remembered for. Whereas Du Châtelet is a contemporary of Voltaire, so just a little bit more recent. And I
I
guess
mean, it's
for
actually fascinating, Dan, that you bring this up because, like in the previous book we were talking about, these women sort of made their way into science in a sense because they could be, paid so much less, and that was like their road in was like in this sort of weird economic system. And then, but when you look back to this particular time, it was like the really, 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 really wealthy ladies of leisure
yeah,
that were able to not get like a formal education, but could pay to have all these like incredible tutors and all this stuff. And so they would end up getting like a high level education and then being kind of in this social situation where they could hobnob with, people like Descartes and Voltaire and all these people. It's like sort of an interesting like reverse thing. It was like if you were this incredibly wealthy woman, you could somehow buy your way to like the
yeah.
status of a man.
Well, it is just fascinating how much the world's changed
Yeah.
between the early 1700s and the beginning of the 1900s. So it's only 2 centuries, but in that 2 centuries, science became, how shall we say, like established, codified. So, there are certain hoops, the PhD system, and so on. And so it was much more clearly defined who was a scientist and who wasn't. Although, as we've seen, people like Pickering was mightily confused thinking that the ladies working for him in some sense were not scientists when they actually were. But, like in the 20th century, at least the way we would frame it today, well, if you're in a university or a university run lab or a government lab or something, and you're publishing papers and you're analyzing data, you are sort of by definition a scientist. Now, what was a scientist 200 years earlier? It's much fuzzier. Again, I mean, the science wasn't really a thing yet, right? So there was natural philosophy. There were people who wrote books about natural philosophy, and who had
And
time
there's
to sit around?
mathematics.
Yeah,
Yeah.
that's right. That's right. So who had time to sit around reading and writing books on these things? And the answer, as you've just alluded to, is the people with the money.
Yeah.
So,
And you can imagine, like, as a woman, so, she did have children, but because she was so wealthy, I'm sure she had, plenty of people taking
absolutely.
helping take care of the
That's right.
children.
Yeah.
And then she was able to, I mean, Janiak sort of says, like, she still wasn't able to go to school or be a part of any kind of, academic setting. But basically, what she did while her husband was off in the army, was she set up at this chateau in the region of Champagne
Yeah.
and it basically created like almost like an intellectual salon, like so she had all these people come, and so it was
Yeah.
like she wasn't allowed in the university, so she sort of made her own.
Or yes, or the, how should we say, the established salons that already existed.
Yeah.
So she kind of invented her own. Yeah,
Yeah.
exactly. So her magnus opus was a book called Foundations of Physics, published in 1740. She's also known for translating Newton's Principia into French. And I guess I'll just say I've mentioned that when Du Châtelet was born, Newton was still around. Newton, of course, he was over in England. He was on the other side of the English Channel. But Newton really casts a substantial shadow over this entire story that Janiak is telling. We'll get into that more later, but let's just say that although the book is about a woman, Emilie de Châtelet, Newton figures very prominently in this story. Something else that Du Châtelet is noted for, she seems to be the first person to declare that what had been happening in the sciences deserves to be called a revolution. So today, of course, you take an introductory history of science course, you learn all about the scientific revolution. In fact, probably just ordinary folks know something about the scientific revolution. But it's important to remember that the people living through it didn't, like Galileo didn't say, well, today is Tuesday. I think I'll start the scientific revolution, or or Copernicus or whatever, right? So obviously that's not how it played out. But now it's the early 1700s. The publication of the Principia is a couple of decades in the past, although it's still pretty fresh. And you have to remember that ideas traveled a little more slowly then than they do today. So yeah, so this question of, oh, something is really changing in the way humankind thinks about nature, about the universe. And she seems to have been on the side that, yeah, these discoveries, breakthroughs, whatever you want to call them, ideas, these deserve to be called a revolution.
She was really at the center of things in a way. Like Janiak tells the story of Voltaire befriended Samuel Clarke. Samuel Clarke is sort of famously was like a spokesperson for Newton.
Yeah,
When Newton fought with Leibniz, it was really like the Clarke-Leibniz
yeah,
debate. So Voltaire went to Newton's funeral. He befriended Samuel Clarke there, and then when he went to live in Champagne with Du Châtelet, Voltaire wrote Elements of the Philosophy of Newton, which was this like sort of popularization or exposition on Newtonian physics. Um, so he was with her, writing this book, and
yeah,
she was the one who was actually helping him understand the math. Voltaire did not know the math.
yeah, yeah.
So that was really her doing. And then, in a way, she came to disagree with certain things that Voltaire put in his book, and she wrote her own, which was this magnum opus that you mentioned. So she was really like kind of at the center of these ideas first being kind of spread, especially in France, but I think even everywhere.
Oh,
And
well,
it's amazing because I had never heard of her.
I was just going to say that, as Janiak points out, the way he describes it, the great task of the Enlightenment was to make Newton comprehensible. And there's something to that. Like some years ago, I thought, boy, it'd be awesome to have my own copy of Newton's Principia. Obviously not a first edition or a second edition or a third edition, because I'm not made of money. Those things would cost many, many tens of thousands of dollars. But I got like an early 20th century edition. It's for people who know their Newtonia. It's Mott's translation, published by Caltech, I believe, in the 1920s or possibly the 1930s. So I'm delighted that now I have it over there on my bookshelf. Do I
That's
ever look at it?
amazing.
Once in a while? Oh, it's I mean it's in English, of course. So Principia was originally published in Latin. Then some years later, an English translation followed. Earlier, I said that Du Châtelet translated Principia into French. I presume that I mean, yeah, Du Châtelet would have been fluent in Latin, so
Yes.
she would have translated it directly from Latin to French, bypassing the English. Yeah, so how often do I look at it? Very occasionally. And does it make sense? No. Like, I mean, it's written in extraordinarily dense, and well, I mean, it would be of no use to a student studying physics in the 21st century. I had to think about what century we're in for a moment. In the 21st century, just because it's written in a late 17th century kind of way, and all the terminology is different, and everything relies on sort of geometrical arguments, and there's all these complicated diagrams. So, of course, if you just pick up a good high school or university textbook today all those same concepts will be there, but written in much simpler language.
Right,
Anyway,
you'll get F equals MA, which is
yes,
like not
exactly.
actually in the Principia.
Well, exactly. Yeah, that kind of thing. So all of which is to say that when Newton published the Principia in 1680s, I guess, or whenever it was, so it's not like you can just pick up Newton's Principia even in, your language of choice, and after a couple of minutes you're like, oh, okay, yeah, comets move like this, and planets do this, and then the moon the moon orbits the Earth just in the same way that an apple falls to the ground. Okay, got it. And now I get Newtonian physics. It's really, for the average reader back then, it would have been much, much more challenging.
Yeah, well, one thing I learned from Janiak, which I was delighted to learn, is that a book you might have picked up at the time was Newtonianism for the Ladies, which was published in 1737. Janiak mentions it in passing. I immediately like jumped on Google and was like, "What is Newtonianism for the ladies?" It turns out it was written by one Francesco Algarotti, and it was like written as a dialogue with, it's like It's like your Fontenelle
Yeah.
example. It's like the ultimate in mansplaining, right? And it's a
Yes.
it's a dialogue of, a smart man explaining to a curious lady Newton's physics, and apparently this book only explains light and color, but not mechanics, because that's what the ladies would have wanted to know. But
Oh man.
one interesting little factoid, which is related to also what you were talking about with Fontenelle, the first edition of Newtonianism for the Ladies has a frontispiece that is a portrait of Algarati, the author, walking with Du Châtelet. So she was also sort of like the lady that this
Yeah.
character is based on in that book as well.
Yeah,
Um,
it's just, I mean, on the one hand, it's so mind-bogglingly demeaning and
right.
insulting. Um, but I will say, if I saw that book at a garage sale, I would grab it up.
Oh, a
Like,
thousand percent, a
yeah.
thousand percent. And actually, I mean, like you kind of do have to. It is sort of amazing that they even existed.
Yeah. Well, I mean, the part that's insulting is that it's aimed at women. The idea of making Newton understandable, that's actually a noble, a noble quest.
Right, right. But the fact that they thought women would want to know, I guess, is
Okay, there
something.
you go. Yeah, yeah, we'll give him, yeah, sure, we'll give him some points. But yeah, that's true. It's not, the attitude could have been worse. The attitude could have been a woman cannot possibly ever understand this, so
Exactly,
let's not try. Instead,
exactly.
it was like, maybe with my help.
Right.
And there's a lot really to sink your teeth into here. As I say, Newton has, sort of looms in the background of this story, and the ideas that are in Newton's Principia. So, for example, gravity. Now Newton struggled with this question of gravity. What is it? How does it work? And for people, again, like by now it's about 20 years later, but people are still arguing, is gravity part of the so-called essence of matter? Now, again, it's funny because we just don't use that vocabulary anymore, right? So by the time I was in undergraduate or whatever, learning some of these ideas for the first time, like we didn't talk about the essence of matter because that's just all that vocabulary died more than 100 years ago. But back then, these were all questions that people were trying to figure out. Like what's the deal with gravity, as Jerry Seinfeld would say? Like how does it work? So Newton had talked about the planets responding to the gravitational attraction. I don't know if he used the word force. I'm actually not sure. But at any rate, he's certainly describing the orbits of comets and planets and also the moon going around the Earth. So these other objects are going around the sun because of this thing that we label gravity, but there doesn't seem to be anything connecting, there's no matter in between, say, the Earth and the sun. So this is a bit peculiar, right? So the predominant way of thinking about stuff, thanks mostly to Rene Descartes, who lived just a little bit earlier, was that I feel like I said this in a different episode of BookLab, and maybe I did, but roughly speaking, if you want to pull a cart full of hay, you better attach an animal to it and have and it's not good enough for there to be a horse standing in front of the cart. There has to be like a harness and some ropes or something attached to the thing. So if you want to pull a big heavy thing, you actually physically have to
Every
pull on
part
it.
has to touch every other
Yeah,
part.
that's right.
Yeah.
Every part has to touch the next part over, or nothing happens. So what's how, gravity seems to be in a different category of pushing and pulling. I mean, again, the sun does seem to, quote, pull the earth, but in a different kind of way. So this was very puzzling. And Newton didn't pretend to have like the ultimate answer to it, and then people on the continent like Leibniz and Huygens, and probably some others just sort of rejected it like that. They just thought it was
To a
uh,
cult, right?
too occult. Yeah, exactly. Like too weird, too spooky. There's this 20th century phrase, spooky action at a distance, which usually crops up in the context of quantum mechanics, but it would absolutely apply here. Like they would say there's something spooky about the sun influencing the motion of the earth when they're, however, 93 million miles apart, and there isn't any obvious stuff in between them.
Yeah, I mean, all these questions of like, right, like what is inertia? Is inertia a force? Is it right? I mean, the whole idea of mass had just kind of been invented in this context. And yeah, I think Descartes talked more about like the measure of things or the volume of things. So all these things were such new ideas. And it's really interesting because looking back on it, like from our perspective, you realize that a lot of these questions actually just can't really be answered by Newtonian physics, right? Like you need general relativity to answer a lot of these questions about, the nature of space and motion and gravity and all these things. So it makes sense that they were confused at the time. But again, as you said, like Newton famously said he feigned no hypothesis, right? Like
That's
he
right.
wasn't trying to claim, I understand how this all works. He was just saying, this is what's happening.
Absolutely. And I was going to save this for later, but since you've brought it up, I mean, the thing that I've been in a just a humorous kind of way, but the thing I've been puzzling is, okay, if I had a time machine, right? So if I had a time machine and I travel back to the province of Champagne in the 18th century, would I be able to talk? Well, I mean, would I be able? I'd have to brush up on my French, and probably the French I learned in school might not even be up to the task. But could I talk physics with any of these people? And as you say, like the terminology wasn't there. So it's just the modern idea of energy, conservation of energy, momentum. I mean, all these ideas were basically unknown. But again, and I think Janiak says this, and I think you also sort of said it, is that this is that just makes it really cool. Like it was a very cool period. Look, it would be fun to be in the villa listening to these folks again if my French was up to it, because it would just be fascinating to see if they were getting it, like what they thought and if they were sort of getting close to how we think of it. Not to judge everything by today's standards, but you know what I
Right.
mean. It would be really, really interesting. So the terminology wasn't there. The ideas, I mean, it's not just that the terminology wasn't there. The terminology wasn't there because the ideas were just beginning to take shape. And just, yeah, a few other thoughts about Newton's role in all of this. So Voltaire, again, Voltaire and Du Châtelet had this very close, presumably intimate relationship of some kind. While, Voltaire thought of Newton, I mean, Voltaire idolized Newton. I think you mentioned that he went to Newton's funeral. Voltaire thought of Newton as almost divine. And he had, so to speak, disciples, right? There were people who really followed Newton's teachings as though they were the word of God or something like that. So Du Châtelet, and this is something that Janiak makes very clear, Du Châtelet wasn't like that. I mean, I'm sure she thought Newton was intelligent, but she was her own thinker. She wasn't interested in being one more of Newton's disciples. She had her own ideas, which she spelled out and which she came to by comparing and contrasting Newton's views to those of a lot of other people who were trying to figure out what space was and what time was and how gravity might have worked.
This is where the book gets very interesting and also where maybe we could be a bit critical as well. But it's like Janiak's task is to then tell us like what did she think
Yeah.
and what made her such an original thinker. And it's very like it's very nitty gritty. The way he sort of like there's not like a very clear thing you can point to. But what's interesting is her book. Yeah, so for one thing, it specifically says like let's not idolize these people. And for another, it ties together what seem like a lot of different competing ideas. And so Janiak points out everyone, even at the time, and this is the kind of sexism of it, wanted to say whatever she was doing, it was like derivative of some great man, right? So
Yeah.
so this book she published, it was a big deal. I mean, it was like translated into many languages. It was discussed by, Kant and Euler and all these people. It was a very big deal even at the time. But, in a sense, because of that, it was like everyone's job was to be like, well, she's just explaining Newton, or she's just explaining Leibniz, or she's just explaining Wolf, or she's, it was all these different people. But the funny thing is, all those people disagree with each other. So it's like the
Yeah.
very
Yeah.
fact that everyone wanted to be like, well, she's derivative of, all these different people, but like you can't be. So
Right.
like obviously she was doing something original. And no one wanted to give her credit for that. But then right, so the question becomes, well, what was she really trying to say? And I think what Janiak's trying to get at is like she was trying to say there was kind of like this question of how do you disentangle philosophy and physics, right? Because you were just saying like this was at a moment where that distinction didn't really exist and
Mhm.
it's
Yeah.
just coming into being. And in a way you had Descartes who sort of started all this in a way, was very like theoretical. Like his stuff was very theory based,
Yes.
whereas Newton was like very empirical. And Descartes, it was like based on philosophical principles. So you had, the
Yeah.
principle of sufficient reason, and like everything has to be based on that. So the philosophical principles come first, and the physics has to be like sort of derived second. And then Newton is sort of trying to say, no, 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 the physics comes first, and like Newton didn't even want to get into the philosophy, but like his disciples wanted to be like, well, the philosophy sort of comes second. They use
Yeah.
Locke's philosophy to sort of like tack on to Newton's
Yeah.
sort of more empirical stuff. And then she was what Janiak says that de Châtelet was saying was that neither one gets priority, that they
Yeah.
really are on equal footing with one another, that they have to be in harmony with one another. And he makes a big point of saying this is not like Stephen Jay Gould's like non-overlapping magisteria.
Yes.
Like it's not like, oh, you let them be in harmony by just like giving each one its own realm and they don't interact.
Yeah.
Like,
Yeah.
no, they're both really involved in all of this. If you want to say here's how gravity works, you also have to say like what are you actually talking about? Like, as you were saying, Dan, like what is it, the essence of the thing? Is it like what do you mean by any of these things? And so she was really pointing out, it wasn't that she was offering up a theory of her own, but she was saying the metaphysics and the physics, the philosophy and the physics aren't in harmony yet. There are cracks in this story that don't
Yeah.
make sense. Like here's Newton's physics and it's great, but until we understand what we mean by many of these things, we actually don't really know what we're talking about. And I think this was sort of brilliant because again, it's like when with the perspective we have today, you can look back and be like, yeah, she was exactly right because you needed general relativity. Like you needed a lot more science to be able to even make sense of the philosophy.
And it's funny as you're describing that. So yes, I agree. I mean, as I said, philosophy and what would come to be called physics were all tangled up, or you could say philosophy and science were all tangled up together. And this time they were just starting to untangle, but that meant there was work to be done. Like untangle them how? Will will the physics be consistent with what we know, with the philosophical principles, as you said? And it reminds me of, and we've talked about this on previous episodes, of course, the situation with quantum mechanics. So in the early part of the 20th century, some very smart physicists said, okay, here's what we know. Here's how quantum mechanics works. It successfully explains such and such experiments, and it's mathematically consistent. Woohoo! Let's party. But as it turns out, that's just the beginning, because then you've got all these questions about, well, what does it mean? What is it? What is the nature of reality if it only exists? I don't have to tell you this, Amanda, because you have written about this at a deeper level than I have. But what does it mean if reality, if the interference pattern is only there if you look at it, right? So all these questions remained unanswered. And in Du Châtelet's time, they had these, we've already mentioned a few of them, but there were questions like Newton's definition of absolute space. Well, okay, I mean, he spells it out in the Principia, but what does it make sense? Is it consistent? Is it a coherent idea? Does it mesh with everything else we know about motion and matter and just the nature of reality? And again, Leibniz and others thought that idea actually doesn't make any sense. You can't have absolute space. I always think of like the grid lines on the holodeck or something like that. Like, and actually, you don't even need the holodeck because even in a regular Star Trek episode, you'll have Spock or Kirk or Picard or whoever talking about, oh, sector J12, or as if there's some way to designate or specify some random location in space, and there just isn't. Now, again, if I know Star Trek fans are going to email me. Well, actually, I only wish we had so many listeners that enough of them were passionate about this, but before anybody emails me to say, oh, no, the way it's done in Star Trek actually makes sense. Okay, fine. But there are issues with this idea of absolute space, and people wrestled with them, and Ernst Mach wrestled with them more than a century later, and then Einstein wrestled with them. So a lot of these questions that were sort of burning philosophical questions in Du Châtelet's time continued to be urgent problems for many, many decades, and some of them we still argue about today.
Yeah, and there's the sense in which what the disciples, people like Voltaire and the kind of fanboy, the Newton fanboys, right? Like
Yeah.
wanted to say was like, oh, now, and this has become the story the kind of like caricature we tell about the Enlightenment. It's like then it was all figured out. There was no more superstition, religion, you didn't have to think about all this stuff. It was just like real science and hard facts and rationalism and all that. And it all made sense. But of course it didn't all make sense. And it was going to break down, when you get Mach and Einstein, all these people start questioning these very like concepts that de Châtelet is like pointing out. So there's a sense in which like maybe if people had taken what she was saying more seriously, we could have gotten there quicker. I mean, who knows?
Hmm.
But it's like it wasn't doing a service to science to try to say, oh, it's wrapped up with a pretty bow and it's all good. We're done. So there's a sense in which really like I think the book is about myth making in science, right? It's like the difference between the stories we tell about science looking back versus the kind of messy, complicated reality at the time. But even more than that, it's even like about the people at the time who are trying to construct the myth and whose voices contribute to that and whose kind of get drowned out.
And in that, I think it echoes the previous book, Her Time, Her Space, because a large part of that book is just coming to understand that, while Galileo and Newton and Einstein are household names, Oppenheimer and a bunch of others, but maybe we've left out some people, right? Maybe there's another dimension in this. So yeah, so I think that sentiment is pretty clear in the second book as well.
Yeah, they make a nice pairing in that sense. I mean, I will say, I think overall, I mean, Janiak's book, it's a little drier maybe than Ghosh's. I mean, it's written by a philosopher, and it's a
Yeah.
little more, for the historians and the academics. And I mean,
It,
I found the story fascinating, but I will say I did feel like it could have been significantly shorter, and it's actually not that long.
yeah, I'll go along with that. It's not that it wasn't sort of fun, but it wasn't. Yeah, it wasn't. It's not oozing with fun like some of the other books we review on the podcast.
Yeah. It tells
Yeah,
an important story, and he's
yeah,
he's clearly done the research, and it's a fascinating like look at the history.
and I'm glad somebody wrote it. Right, this was a book. This
Exactly.
was a book that
Exactly.
somebody desperately needed to write, and here we go.
Yeah, me too. I mean, in the spirit of this episode, I think it's important to point out there was a previous book about Du Châtelet by a female author named Judith Zinsser. So there was a book called Amélie de Châtelet, Daring Genius of the Enlightenment by Judith Zinsser. And this came out in 2007. So I just want to acknowledge that. I mean, our podcast, we look at books, that are just coming out right now. And so that's why we're
Yeah.
focusing on this one. But it's I'm definitely curious to read Zinsser's now and see what the differences are. But yeah, I mean, this was a really interesting look at the history and I guess the takeaway in some sense when I think about, Janiak's characterization of Du Châtelet as like the Enlightenment's most dangerous woman, you can say, well, what was so dangerous about it? And
Yeah.
I
Yeah.
think, when you look at the quote at the beginning of her magnum opus where she says, I advise you not to carry respect for the greatest men to the point of idolatry, as do the majority of their disciples. In a way, yes, she's telling anybody, don't idolize these men and like think for yourself, but she's also sort of telling women, you don't have to idolize these men, you can think for yourself.
Mm,
And I
yeah.
think that's what made her a dangerous woman. Again, the book is The Enlightenment's Most Dangerous Woman, Amélie de Châtelet and the Making of Modern Philosophy by Andrew Janiak.
You've been listening to episode 36 of BookLab. You can find us on Apple Podcasts and on SoundCloud. Follow us on Facebook at facebook.com/booklabpodcast. And do look for Amanda and myself on your favorite social media platforms, including Blue Sky.
Thanks for listening, and we'll see you next time on Book Lab.